we are going to look at the sine and cosine ratios up to 180 degrees. So from 0 degrees to 180 degrees, we'll look at the sine and cosine ratios. Sine. If you wanted to find the sine of these angles up to 180 degrees, we'd make jumps of 30 so that we have a couple of values between 0 and 180. You could find, by using your calculator, you can plug in 0 for x, sine of 0, and find 0. The sine of 30, your calculator will tell you that that's 0.5. Sine of 60, your calculator will say that's this. Okay, so if we find the sines of these angles up to 180, you get these values, and you can plot this as points on a graph, like we do with lines, like we've done with quadratic. Have we done that? Yes, we have. Reciprocal graphs, exponential graphs. This is just like it. You make a table of values and you plot the points, and then you connect them with a nice smooth line. This shows us the shape of a sine graph for the first 180 degrees. After this, actually, it goes down and then back up. But for today, we're just going to look at this nice little bump. That is what a sine graph looks like between 0 and 180 degrees. And we found it by plugging in angles for x and using our calculator to find the sine of these angles. Well, you could do the same thing for cosine. Here we picked the same angles to plug in for x. So we found the cosine of these different angles. And this is the values that our calculator gave us. Once again, you just plot these coordinates on a graph. The graph goes from 0 degrees to 180 degrees. And these are the y values. Here our graph goes below 0, because here we see the cosine of 120 degrees is actually a negative number, so it goes under 0. Whereas the sine graph, it was all plus numbers, right? The lowest was that 0. And the cosine one starts at 1, goes through 0, and goes further down to -1. Right, you plot your points, make a nice line, and this gives you a cosine graph. Now, we just want you to understand or to be familiar with the shape of it, how to find the values to draw the graph of a cosine or a sine curve, and then we can use these graphs that we made to solve very simple problems. For example, if we said solve this equation for x. So what is the value of x? The sine of some angle that we're calling x equals 0.4. Okay, and find all the possible solutions for x between 0 and 180 degrees. How would we do that? We would actually first get x on one side, right? X would actually equal the inverse sine of 0.4. You've seen that before. The inverse sine of 0.4 is x. You can plug that into your calculator. Usually you put 0.5 and then hit inverse sine, and it'll give you the x value. If I do that in my calculator, it tells me that x equals 23.6 degrees. So the inverse sine of 0.4 is 23.6 degrees. Let's pull up our sine graph. this good? Yes. This is our sine graph. And we can actually see that that's true. Where is the sine of x 0.4? Well, that would be on this line, right? If we draw a line where y equals 0.4, that's this line, we can see where it touches, and that is here. And you know, if we make an estimation, that does look like 23.6, right? That could be 23.6. This is 10, 20, this is 30, so 23.6. That looks right. But as you can see on this graph, if we're looking for solutions up to 180 degrees, there's actually another angle where the sine is equal to 0.4. And that is here. This is the other place where y equals 0.4 meets our sine curve. And that would be exactly there. And because this line, this nice bump, is symmetrical, and this distance is 23.6 degrees, we know that this distance from 180 to our other x value, that is a solution to our problem, is also, it's 23.6 away from 180. So this is not our only answer. We have another possible answer, which equals 180 degrees minus 23.6 degrees, and that equals 156.4 degrees. So there is two possible answers for x within this range, right? If we say up to 360 or 720, however far you want to go, there could be more answers, right? But we are just looking at the interval between 0 and 180. These two numbers are between 0 and 180. Okay, that one's nice. Let's do one with cosine. So the cosine of some angle is equal to 0.624. We can plug that. Oh, wait, I have to change this. X then is actually equal to the inverse cosine of 0.624. And this you can plug into your calculator to find the x value. You would say 0.624 inverse cosine, and it would give you the angle 51.4. But we haven't forgotten what happened with our sine graph in the other problem. We're looking for any possible answers between 0 and 180. So let's look at the graph and see. Okay, so cosine of x was 0.624, which would be a little here. Does that look right? Yeah, that looks right. So it would be around here, right? This is where they touch. And that would, this is 30, 40, 50, so it's a little over 50. And that looks right because we got 51.4. Now, if we want to find all the solutions for this equation, we want to continue this line to see whether it touches our cosine curve anywhere else. And as you can see, this only touches once. So between 0 and 180 degrees, there's only one angle that has a cosine of 0.624, right? So this is our only answer for x. So be sure to use the graphs to see, am I looking for one answer or for two? And practice using your calculator correctly to find inverse cosine and inverse sine and then just have fun with it.